An influential observation is one that has a disproportionate effect on our regression model. In other words, we could imagine fitting our regression model both with and without the observation, and then we'd consider an observation to be influential if it substantially affects the value of model statistics such as the slope coefficient and the y-intercept. Now, in general, influential observations typically exist when the observation is an outlier relative to the other x values. So in the graph displayed here, we might find that case 1, which is an outlier on the y dimension, may or may not substantially affect the regression model, and so we may or may not call it influential. Case 3, which is an outlier on the x dimension, would be more likely to affect the regression model, and so we'd be more likely to call it influential. Case 2, which has high values on both x and y, but appears that it would lie close to the regression line, might or might not turn out to be an influential point. So let's look at a few more examples. Consider the following scatter plot. We have XY data that seems to generally follow a linear pattern, but we notice one point up here with a high value on the y dimension, and it seems like a bit of an outlier from the pattern of the rest of the data. Well, let's fit a regression model to this data. We get the model y hat equals 23.06 plus 2.23x. And we notice that the regression line appears to fit pretty well through the main pattern of points. But now, let's remove this point that seems like a bit of an outlier, and then we'll re-estimate our regression model. Now here's our new regression model that was estimated without that unusual outlier point in our data. It looks like a pretty good model. The regression line seems to fit the data pretty well. But now let's try to pull up these two graphs so we can compare them. And we can see that when we remove this outlier from our data and re-estimate the regression model, the regression line doesn't really change very much. In fact, we can see that the regression line moves from 23.06 plus 2.23x to 22.33 plus 2.35x. And so, it's pretty clear that these regression models aren't affected too much by the inclusion of this one data point. So we'd probably be inclined to say that this point is not influential in our regression model. Now, let's look at a similar data set where we have an outlier in the x direction. You notice here that we have an outlier point that's not following the pattern of the rest of the data, and you notice it's very high on its x value. Now let's fit a regression model to this data. And we can see pretty clearly that the regression line isn't fitting through the general pattern of points, but rather its slope is being sort of cranked down in the direction of this outlier point. So now, again, let's remove this data point, and we'll re-estimate the regression line. And we see that our regression line now fits the pattern of the points very well. So again, let's put the two graphs together to compare. And when we look at the original data on top, we see again that the slope of the regression line is being cranked down toward the outlier. But when we remove that point, the line snaps back up and fits through the general pattern of points. We can also see the effect by comparing the regression equations. The original equation with the data including the outlier is 25.69 plus 0.99x, and the new equation is 22.33 plus 2.35x, which is clearly a substantial change, particularly for the slope.